In 1952, I started working on the gum from Acacia cynophila, which is now called Acacia saligna. Acacia cynophila is generally known as the Port Jackson willow. It's also known as Western Australia's golden wattle. During the 1800s, some of these trees, Port Jackson willow trees, were brought into South Africa from Western Australia, and the trees grow extremely well in sandy areas near Cape Town. Acacia cynophil trees do not produce vast quantities of gum, but if I went collecting for half a day, I could normally bring back a couple of 100 grams of crude gum, cynophila gum. I was much better off than Fred Smith, because in 1945, Partridge, who was working at a low-temperature research lab in Cambridge in England, introduced paper chromatography into carbohydrate chemistry, and 4 years later, Huff, Jones and Wadman, who were working in the chemistry department at the University of Bristol in England, introduced cellulose column chromatography into carbohydrate chemistry. In this day and age, most organic chemists use thin layer chromatography, which is ascending chromatography. If you use paper chromatography, you get much better results if you use descending chromatography. So I needed to get stands made which could fit into my chromatography tanks, which were about 1/2 metre tall. We bought these tanks from the Cape Town post office. At one time, they'd used them for storing sulfuric acid. Now, the stands had to be made so that at the top they could hold troughs which could be filled with solvent mixtures, and one edge of the paper dipped into the solvent and the rest of the paper hung down. All this meant that I had to deal with the most difficult glass blower, and I had to develop monumental patience. Eventually, he made the stands and the troughs. He made me a column for chromatography, and he made me an apparatus which could be filled with liquid stain, and when I connected that to carbon dioxide cylinder, I could spray the stain onto the paper chromatograms. Most people might be completely unimpressed with the fact that I was using what used to be called string and sealing wax science. However, I should like to point out in 1952, Martin and Singh, two British chemists who got the Nobel Prize for introducing paper chromatography into chemistry and biochemistry, ran their paper chromatograms in a drain pipe. I've actually seen a photograph of their apparatus. Over the years, the United Kingdom have had many very imaginative and highly creative scientists. I once visited a university in Basel in Switzerland. The person I spoke to had then recently returned from the United States, where he'd been working in Woodward's laboratory at Harvard. He said to me, "We in Switzerland can do experiments which the Americans wouldn't even try to attempt. But when it comes to imagination, the Americans and particularly the British can beat us hands down." That fellow didn't mention Southern Ireland. In 1960, Barry and some other workers in the chemistry department at the university in Dublin were very imaginative. I understand that they had very little money. They did a lot of thinking, mainly in the pubs, and every 10 years or so, they completely revolutionized the area in which they were working. Anyway, once my chromatographic tanks were working, my column was running, I was able to show without too much difficulty that Acacia cynophila gum was made up with the same monosaccharides that make up gum arabic, but the different monomers were combined in different proportions in the two different polymers. I found that in cynophila gum there was a good deal more glucuronic acid than there was in gum arabic, and there was also a good deal more L-rhamnose. The mole ratio of L-rhamnose to D-glucuronic acid was nearly 1 to 1. I studied Fred Smith's papers and found that in gum arabic, the mole ratio of L-arabinose to D-glucuronic acid was also nearly 1:1, but Fred Smith had made no comment about this. A few years before I did this work, my supervisor, Alistair Stevens, worked out the structure of the gum from Acacia mollissima, which is the black wattle. Alistair also found that the black wattle gum was made up of the same monosaccharides that make up gum arabic, but again the monomers were combined in different proportions in the two different polymers. Alistair Stevens found that in that case there was less glucuronic acid than in gum arabic, and there was also less rhamnose than in gum arabic. But again, the mole ratio of L-arabinose to L-glucuronic acid was nearly 1:1, and like Fred Smith, Alistair Stevens made no comment about this. The fact that these three different gums had L-rhamnose to D-glucuronic acid in molar ratios 1:1 made me think. At first I thought the results might indicate a significant biochemical connection between D-glucuronic acid and L-rhamnose, but I was unable to write out a pathway linking these two monosaccharides, and I had to give up that line of thought. And then a very simple idea struck me. From the formula, it can be seen here that if you make R prime L-rhamnose for gum arabic and also for Acacia cynophila gum and also for Acacia melissa gum, you can understand why the molar ratios are 1:1 in all three cases. So when I came to write my thesis, I suggested that L-rhamnose was linked to the 4th position of D-glucuronic acid in gum arabic, in Acacia cynophila gum, and also in Acacia melissa gum. I pointed out that E.L. Hurst, one of the leading authorities on carbohydrate chemistry, had come to a different conclusion for gum arabic. He'd made R prime L-arabinose. After my thesis was submitted, we published a paper on Acacia cynophila gum in the Journal of London Chemical Society, and there we also stated that rhamnose might well be linked to the 4th position of glucuronic acid in gum arabic, in Acacia cynophila gum, and in Acacia melissa gum, and there was a reference to my thesis. In 1959, Fred Smith and Rex Montgomery brought out their monograph on the plant gums and mucilages. And in that book, they also suggested that L-rhamnose was linked to the 4th position of glucuronic acid in gum arabic, and their reason that because the mole ratio of L-rhamnose to D-glucuronic acid was nearly 1:1.